Hi, so this is my screencast for Multiplayer Distributed Games Programming CA1 design document. So like to start off showing the overall view of what the game will look like. The game's called Orion, and the genre is a MOBA, or mobile action game. So we have a red side and a blue side. For the alpha version of the game, this will be one player versus another player. One using keyboard and the other one using an Xbox controller. So the gameplay is as follows. Each side has a gem, and the goal of the game is to destroy the other enemy's gem. So when you start the game, you start off at these positions just in front of your gems. For the beta version with the multiplayer, there's two separate lanes that the players can go to, and this combat will all take place around here, competing to get into the center square. So players can jump in from here or fall in from the top. The reason that they need to get here, and this is a contested zone, is to get the stopwatches. The stopwatches turn off the turrets. Turrets have a bounding box around them to detect collisions with the player's bullets, but around that is a bounding sphere, which detects whether the enemies are in range. If the enemies are in range of the turret will then fire in the straight line towards the center of the player. By turning these off with the stopwatch, it then allows them to be destroyed. Only once both towers are destroyed can the enemy team destroy the other team's gem. So this gem is locked until these are gone. The smaller minions have some basic pathing, moving back and forth, and spawn periodically. When these are killed, they drop a health potion. The health potion can then be picked up to increase their health bar, which is shown down here. This green bar is separate from this overall image to change the bounding box and what's shown on the HP bar as it moves down. In the bottom right, we can see an overlay. These circles will be filled to display the player's abilities. So the player's abilities fall into a left click to shoot, a right click for a power shot. Pressing W will jump. Pressing S will allow them to fall through platforms. Now the platforms aren't placed in this yet, but one platform will sit here in the middle, and another platform will sit just above the stopwatch to allow the players to get back out into the top lane. When a player presses S further down on the platform, they'll fall through. And the last one is a timer, so there'll be a timer animation counting down from 5 for when they can use their next power shot. So your win scenario is to destroy the enemy nexus, but your loss scenario is if you are killed by an enemy player. Getting killed by a turret also counts this way. So the game story is set in this intergalactic battleground to solve and settle disputes through combat. So as I talked about with that, the game input falls into keyboard for player 1 and Xbox controller for player 2. WASD is your up, down, left and right movements. Up serves as your jump, and down serves to fall through the platforms. The same transfers over to the Xbox controller, where the left stick is used for the movement instead, and the right trigger and left triggers are to do the attacks. So for the game input code, I've just put the way that they would be implemented in the game. In constants.h, all the variables are declared, so your WASD and how they'll work. There will be some added in code there for moving through platforms, and a little bit on how the gravity works with the jump. So then just talking about the mouse inputs, and finally the Xbox inputs. Moving into the game sprites. The game sprite for the turret is taken from the 2D game Awesomenauts. So when I talk through a little bit about how the collision will work here, a bounding box around and then the bounding sphere. When a player enters that bounding circle, the turret will start firing. They're in the form of small red shots in the direction of the player, shooting from the barrel to the center of the player. These shots all contain a bounding sphere, and the action triggers a sound effect. Again, as I've talked through the platforms, pressing S will drop you through it. You can see it's semi-transparent, and pressing W will let them jump. Then we have the health pickup. This isn't shown in the image at the top because this health pickup will be only shown when an enemy is killed, which are these minions here. These have the basic pathing, moving in the X direction back and forth. And the translation for their bounding sphere, you can see the overall shape of this is a sphere moving around. Finally, the stopwatch, another bounding sphere. The watch is drawn to screen based on the pickup time and the elapsed game time. So the time that the last watch was picked up, subtracted from the elapsed game time, will give the overall time. And if this is greater or equal to 10, it will draw another watch to screen. Pickup time is only declared from the last time or the first time a watch is picked up. This means that we won't have watches drawing over watches. You can see some of the more basic elements of the game background, and the game background with the collidable floors. We have our UI overlay, which will have circles placed within these. This one will be an animated circle. Finally, we have our gems. The collision is not on the gem itself, but rather on the yellow box around it. And we have our health bar as explained before, and finally the logo for the game. So all of these textures, although they have been semi-resized for being placed into the document, all of them are actually multiples of powers of 2. So we won't have problems with the source rectangle parameters when putting that in. So in that sprite implementation, I just talked a little bit how the draw sprite and the draw method works, as well as the sprite data. So just moving through, pretty straightforward with the code that it finds the center, places it to a screen position, translates it to a target location based on that sprite data, scales and flips, although I don't think that will be necessary. All the sprites are in the correct horizontal position, and it creates the matrix to rotate scale for the collision and physics for the game, which is talked about a bit below, and then they're then sent to the draw method. So the background music for the game, diegetic and non-diegetic sounds, and we have these basic sounds all contained within file submitted with this assignment. Some of them still need to be processed. Some of them are MP3s, the rest are WAV files. These are taken from sound libraries online or from sound assets from youtube.com. The background music itself comes from the game Awesomenauts, the same game which I used the turret sprite from. For the sound implementation, I'll be using Zact, which I used last year for the same purpose for a 2D game. So apart from the background music, all non-diegetic sounds are trigger-based events. So they're all played on cue of when an event occurs. So where the player shoots, this obviously being replaced with the player shooting sound in file, will cue the sound to play. For stopping sounds, the Zact flag soundback stop immediate will be used for all non-diegetic sounds. This is due to the nature of these sounds, that they're all event-based, so that they'll only play once or played at the necessary times. So when a turret is shooting, it will only play the sound for as long as the player is within the outer bounding sphere. Oops. So here I just put in the player sprites and these animated sprite sheets. Red side obviously for red and blue side for blue. This is the jump sprite, which will replace the running sprites through when the player jumps. The two types of collision that I'm using for the game are bounding spheres and bounding boxes. Bounding spheres take up the most of the collision detection in the game, and using the distance calculation formula to get the intersections. The other type is the bounding box, but these only occur in two places. The turret sprites, which do not move, they'll use a regular bounding box without the need for any translation or rotation. This is just down to the turrets that they don't move. The player sprites will have to use a rotated bounding box. So inside the entity class, I looked at the collide rotated box. So essentially what we're doing here is just setting the collision vector by computing the rotated box. The computations for the box come here. They're applied at corners in an array called corners, taking edge 1 and 3, using this formula for getting these edges. These edges are then projected onto the origin, and a projection vector is gotten from the dot product of the first edge of the base corner to the corresponding vertex on the other box. The entity class creates a vector and a matrix 2D. These contain length, dot product, and normalizing the vector. So just going through there, the code is what I explained before. Getting the corners and then using that formula to get edges 1 and 3. Then using edge 1 and 3, we define the minimum and maximum parts for the projection to see if there is any overlap. As far as networking goes, all I talked about here was what we're using. The game itself will use a UDP connection for the networking code. This is due that the player only cares about what the most recent information was. Like example is where the character is on screen or when the last turret fired. The player doesn't need to know what was lost essentially with the frame beforehand. The chat system, however, will use a reliable TCP connection to ensure that all chat data is preserved and sent effectively. The way that I'll implement the chat system is using a TCP connection with a go back N algorithm. So this algorithm will check for acknowledgements sent back and forth between the client and the server to see if the packets were received. If not, it will resend the packets before and delete the packets afterwards. So if it sends packet 345, it will delete packet 5 if 4 isn't received, and an acknowledgement will be sent that the packets weren't received. So in reality 3, 4, and 5 would be deleted and then sent again. So this is the overview for my game. Ultimately why I think this game will be effective is because it's within the scope to do for one person over this time frame, as well as being an overall fun game to play over a network with multiplayer. There's a lot of combat, very fast-paced action, and what I'll be looking to implement is some sort of death timer, so the player gets redrawn back at the start if they die, and we'll have a death count. This can be placed up where the Orion logo is at the moment, where I can have a count displaying the integers of how many times each player has died. So that's my game. Thank you very much.